Welcome to qnawire.
Right, so we're given two functions, f of x and g of u, and asked, are these two equal to each other? So how do we determine that? Well, two functions at their most basic definition are equal if both of their domains are equal, and then if for that domain, if both functions f of x and g of u are equivalent have equivalent outputs for every single input. And so I'll show you what that means in just a sec, but let's check the first part of that rule out. Are their domains equal? And so let's take a closer look at f of x specifically. We're told f of x is equal to x plus the square root of 2 minus x. So looking at the equation, what is our domain? Well, we've got a radical here, and so we know we've got to take a closer look at that. What goes under the radical needs to be greater than 0 because we can't have any imaginary numbers in our function. And so adding that x over to the other side of the inequality, we can determine that x needs to be less than 2, or that our domain is going to be all real numbers less than 2. Cool, so let's do the same thing for our other function, g of u. We're told that g of u is equal to u plus the square root of 2 minus u. So again, we've got another radical, and so we know that the expression under the radical, 2 minus u, needs to be greater than 0. And so doing the same thing we did with f of x, we determined that 2 needs to be less than u, and so our domain is going to be, again, all real numbers less than 2. Awesome. So we determined that both of our domains are equal, right? Because they're both equal to this all real numbers less than 2. So that's half the battle right there. But next we need to determine for the domain, for all real numbers less than 2, do f of x and g of u have equivalent outputs for every single one of those points? So first, let's just go ahead and plug in a random number that fits here. And so I'm going to try x and u equals 0. So let's plug that into our equations. We have f of x is equal to x plus the square root of 2 minus x. And so if we plug 0 in there, we get 0 plus the square root of 2 minus 0, which is just equal to the square root of 2. Awesome. So let's do the same thing, but with g of u. And so again, I'm going to set that argument equal to 0. And so we know g of u is equal to u plus the square root of 2 minus u. And then I'm going to plug in a 0 wherever I see a u. And what do you know? We end up with root 2 for both problems. But I know what you're saying. Okay, so they f of x and g of u are equal for one value of the domain when x and u both equal 0. But how do we check it for every single value? Because that's what we really need to be doing here, right? And so I want to show you what happens when we just look at the functions with function variables themselves. So rewriting f of x, we're told f of x is equal to x plus the square root of 2 minus x. And so now, just like we did with the value 0, instead of replacing x with 0, I'm going to input u as my argument. And so everywhere I see an x, I'm going to plug in a u instead. And you can see when I do that, I get an identical expression as to the one that we're given for g of u in the beginning of the problem, that u plus 2 root minus 2 minus u. And so doing the reverse of that, I'm going to plug x into g of u. And what do you know? We get the same exact expression that we were given for f of x in the beginning, because g of u, as you remember, is equal to u plus the square root of 2 minus u. And when we plug an x in throughout the that equation, wherever that argument pops up, we end up getting the exact same equation. And so knowing that u and x both have equivalent domains, that means that whether or not it's a u and x, whatever variable you plug in, both equations, f of x and g of u, are going to be identical. And so the answer to our problem is yes. F of x is equal to g of u.